Okay, so let's start chapter 2. So this is about statistics in chemistry, no? So why do we care about statistics chemistry to? Number one reason is that chemistry, or let's say analytical chemistry, is a chemistry that is heavily focused on measurement. Okay, so whenever you are doing measurement, statistics must be included doon sa topic na yon. Okay. So sabi nga natin, chemistry is heavily reliant on statistics, no? And when we are doing measurements, there are rooms for error. Maraming error na pwede ka ma-encounter during your measurement time, no? So that means we really have to understand statistics, no? Because statistics will help us to check whether our data agrees with one another, or it could also help us to decide whether we can accept or reject our hypothesis, no? Okay, so yung sa hypothesis testing, that is t-test and ANOVA, hindi natin gagawin yung mga yon. Okay, so we're not going to use the f-test, t-test, ANOVA because they will be discussed in your biostatistics naman. For the purpose of this topic, ang i-cover lang natin is yung means of means of measuring the central tendencies and how to check whether spread out yung data mo or not, and uh, what are the corresponding tawag doon? What are the corresponding meaning? Okay, so ganun lang. What are the corresponding meaning with your statistical data? Okay, so yun yung gagawin natin. So ano ulit, alamin lang natin how to measure the central tendencies of your data and how to interpret the spreadness of your data. Okay? Kasi kapag spread out yung data mo, it could mean something. No? Pag hindi siya spread out, it could also mean something, which we will discuss later on. Okay? So the basic statistical tool na ginagamit when doing measurement is the measures of central tendency. So when we say measures of central tendency, we are determining what are the central values for our overall data. Kumbaga, we are looking at our data as a whole, and then we check saan sila nag-agree sa isa't isa, or saan sila patungo, saan yung pinakagitna nila. Okay? So that means we are checking where the central location of a distribution is, no? Saan yung pinakagitna ng overall data? Because that will be the representative of our entire measurements. Okay? So there are three basic measures of central tendency. We have the mode, the mean, and the median. Okay? So let's talk about those three first. So let's start with mean. Nabubulol na. Let's start with mean. Okay. So when we say mean, that is just the average. Okay. So we know the formula for average. You add all the values divided by how many measurements you have. Okay. So in equation form, that is x bar, meaning yan yung average. X bar is equal to the sum of x, meaning the sum of all your measurements, divided by how many measurements you have. So that is the way you get your arithmetic mean, or just the average. Okay. So for example, we are given this data. We have the water hardness data in ppm. Calculate the mean. So what you're going to do here is to add all the numbers first. Okay. So paki-add natin sila. So we have 310, 314, 325, 300, and 327. So let's add them. Sabay na lang kayo sa pag-add, ha. Kanya-kanyang add na to. Daming numbers eh. Okay, so the sum of our data would be 1576. Okay, so for us to get the mean, so the mean is just x bar equals the sum of x divided by the number of your measurements, okay? So that will be the sum of x is the sum of your measurements. Ito yon, 1576 divided by how many measurements you have. So we have 5 here. So that means x bar is 315.2. Okay? So yan. That's how we solve for the mean. Alam nyo na yan, no? Elementary pa tayo, ginagawa na natin yan. Next one is the median. When we say median, we are pertaining to the middle result of our data when they are arranged in from lowest to highest na. Okay? So, yun yung median. Kung ano yung nasa gitna ng ating data, yun yung median. Okay? So, our median could have two possible ways, no, para ma-determine mo yon. One is kapag odd number ang iyong data, whatever is in the middle of your data, yun na yung median. However, if ang iyong data ay even number, ibig sabihin nun, kung ano yung nasa gitna na data mo, i-average mo siya. So, paano yun? Let's have this one for example. We have the same data, just like yung nasa last slide. So, we have the water hardness in ppm. So what you're going to do first in order for you to identify the median is that you arrange them from lowest to highest. Okay, lowest here, highest there. Then bilangin mo ilan sila. We have 5 data points here. So ibig sabihin odd number yung ating data. So that means whatever is in the middle of the odd number data, yun yung ating median. Okay. So paano ma-determine yan? So what I do personally is I cancel out the outer parts until I arrive with the middle number na. No? So, kinakancel ko muna yung mga nasa dulo, followed by yung susunod sa kanya. Then, whatever is left, that is my median. Okay? So, ganun din. Pwede nyo rin gawin yan. Kaya, tignan mo lang. Makikita mo naman agad eh. Pero kapag marami yung data points mo, di mo agad siya masasabi. So, ganun. So, that's for odd numbers na. Kung ano yung nasa gitna, that is the median already. What if even yung numbers mo? So, let's say we have this data points. We have 6 data points here. So, you arrange them from lowest to highest. Then, you cancel out the outer data first, no? Yung nasa labas, cancel. Followed by kung ano yung nasa loob. And then, since ito ay even numbers, yung nasa middle mo ay dalawang numbers. Yun yung matitira. So how are you going to get the median? You get the average of the two numbers left, no, in the middle. So kunin mo yung average niyan. So that will be 310 plus 312, 314 divided by 2. So that will be 312 ppm. Okay, so ganun lang. Again, if odd number yan, whatever is left in the middle, that's your median automatically. If yan ay even numbers, then you have to get the average of the two numbers in the middle of your measurements, okay? Of your data set. So, ganun lang. Last one is the mode. When you say mode, we are talking about the most frequent value, okay? So, sometimes may mode, sometimes wala, okay? So, our data can also have one mode. Pwedeng isa lang yung ulit na number. Or it could be bimodal, trimodal, etc. Okay? So, when you say bimodal, dalawa yung number na nauulit. No? So, ganun. So, pwedeng marami. Okay? However, for the purpose of this class, kung ano lang yung pinaka-frequent value, yun na yung mode niya. Okay? Kung sino yung pinaka-madalas na naulit, siya na yung mode. Okay? Pero in statistics in general, pwedeng maraming mode. Okay? Pwedeng maging bimodal yung data mo, and etc. Okay? So for chem, kahit isa lang yung mode natin, okay lang. Pag walang mode, okay lang din. Okay? So, yan. So, for example, we have this data. So, we have the water hardness data. You check anong number yung nauulit. So, looking at these numbers, we see that 325 was repeated twice. Okay, so that means that will be our mode. That is the number that is repeated frequently. Other numbers are just mentioned once naman na. So, yung 325 talaga yung mode natin. Okay? So, yan. So, yun lang yung basics, no? Again, what is the purpose of the measures of central tendency? They let us know where our data is heading to, or where is the central measure of all the data points that we have. Okay? Titignan na natin yung overall overall outlook ng ating data. Okay? So, ganun kasi, it is always the middle ground na tinitignan na when doing measurements. Okay? And then, ano pa yung may tutulong yan sa atin? Okay, one purpose of doing statistics in chemistry is that it can actually tell us whether we are precise or accurate, no, when doing measurements. So when we say precision, it refers to the closeness of your data points or your measurements. When we say accuracy naman, it refers to the closeness of your measurements to the true value. Okay? So yun lang yung difference. Accuracy, the closeness of your data to the true value. When you say precision, the closeness of data to each other lang. Basta dikit-dikit yung data mo. Okay, how do we determine if we are accurate or not? No, one way of checking for accuracy is the error or the percent error. May formula yan, no? So, percent error can be determined using the formula experimental value minus true value in absolute value over the true value times 100%. Okay, so ganun. So that's how we determine the percent error. If your percent error is very high, that means you are not accurate, no? Hindi accurate yung measurement mo. Okay? However, if your percent error is low, then yun, accurate yung measurements mo. There are certain percentage na ina-accept dito. If you're familiar with the 5% no limit, especially ginagamit yun sa hypothesis testing, di ba? Yung 5% or the 95%. No? So yun, yung 5% limit that can be used as the limit for the percent error. If you exceed that, then wala. Pangit na yun, hindi ka na accurate. Anything lower than 5% could be considered accurate na. Okay, so ganun. That is set naman by the question or by the ano by the operation stuff. No? So nasa ano na yan, nasa work na yan. Pag nag-work kayo, isa-set talaga yan. Kailangan, ito yung percent error nyo. Pag lumagpas kayo dyan, ulit kayo. No? So, ibibigay naman yun sa inyo. That is given always. Okay? So, ayun. Anyway, so let's proceed. Let's talk about precision naman. So when you say precision, it refers to the closeness of data to each other. Okay. So it doesn't necessarily mean na kapag precise ka ay accurate ka. No. Basta ang data points mo ay dikit-dikit, then you are precise. So how can we tell if our measurement is precise? No, we can use the spreadness. Okay, so when you say spreadness, we are actually pertaining to the uh, re- standard deviation. So standard deviation, discuss natin later yan. Okay? Okay. So anyway, so mamaya na natin discuss yung standard deviation. Okay, so again, how do we determine if a measurement is accurate or precise? So when determining if your data or your measurements are accurate, you have to check the percent error. Okay? And the formula is given doon sa right side ng PowerPoint. Sinulat ko siya. So that's experimental value minus the true value in absolute value, just to remove the negative sign if there's any, divided by the true value times 100%. Okay? So, if mataas yung iyong percent error, then you are not accurate. If mababa yung percent error mo, then you are accurate. Okay? Pag sinabi naman precision, it refers to the closeness of your data to each other. Okay? Not to the true value, but to each other. And that is determined by determining the spreadness of data or the standard deviation of your data points. Okay? So, mamaya discuss natin yun. Ano ba yung pinaka-importance na itong lahat, no? Kasi, sa measurement, there are errors, sabi ko, di ba? And there are types of errors that could be determined, and there are errors that cannot be determined. What we're trying to do with statistics here is that we're going to check whether our errors can be determined. Okay? Pag tinignan mo kasi yung standard deviation, it could tell you na may ganitong error sa measurement mo. If masyadong mataas yung standard deviation mo, then there is something that could be determined. No? May error na pwede mo malaman kung saan nanggaling yung error na yan. Pero kung mababa yung standard deviation mo, then it could be from random errors lang or indeterminate errors. So there are three types of errors that we encounter when doing measurements or when doing chemical experiments. No? One is the random error or the indeterminate error. Second one is the systematic error or the determinate error. And the last and the bad one is the gross error. Okay, so let's talk about these three types of error that we encounter in laboratory experiments. No? So let's begin with the random error. Random error is also called an indeterminate error. So from the word itself, indeterminate, this is something that you cannot determine, you cannot control. Okay. So there are other factors that could be attributed to this, no. Pwedeng about na yun sa physical property ng matter, no. Siguro yung matter, ganito yung behavior niya ngayon, mamaya hindi na. So yun yung mga random errors na pwede mag-arise. Okay. Pwede rin yun sa ating glasswares, no? Remember, our glassware may expand, may contract over time. Kahit naka-aircon yan, pwede yan mag-expand or contract. Okay? So, those errors that you cannot control kasi hindi mo naman mapipigilan yung mga objects gumalaw-galaw at a short distances, no? So, wala na tayong magagawa doon. So, they will be present pa rin talaga kahit anong gawin mong control sa sarili mo. Okay? So, those are the errors that can be accepted. Ito yung mga katanggap-tanggap na errors. Okay? So, you can determine if you have random error if your standard deviation is low. Kapag mababa yung STDev nyo or standard dev, most likely, random error lang yan sa measurement. Okay? And since this is present everywhere, okay? Sabi ko nga sa class ko last, tawag dito sa random error ay innate na sa measurement. Bakit innate? Ibig sabihin, andun na talaga yan sa measurement. Hindi mo siya mapipigilan, okay? So this is something that is in measurement and we should accept na may errors talaga such as random error. So minuscule lang yan. So ibig sabihin, maliit lang yung error na yan, okay? However, the problem is when your error starts getting big. Hindi na random error yon. So it could fall under the systematic error or the gross error. Kunwari, nagtitimbang ka, dikit-dikit values mo. Pero may onting discrepancy. Yung onting discrepancy na yon, we call that the random error. That's okay lang. However, if ikaw nagtitimbang ka, then halo-halo na yung mass na nakita mo, iba-iba na yung values, most likely, may dalawa kang other types of error pa. You either have systematic error or the worst one is the gross error. So let's talk about systematic errors first. Systematic errors are called determinate errors. Why? Because you can determine them. Okay? And there are three factors or there are three types of systematic error. or there are excuse me. There are three types of errors that could lead to systematic errors. No? So one of which is the instrument error. Okay. ano yon? So, pwedeng yung error galing sa instrument. So, suppose natin, kunwari yung volumetric flask nyo, basag pala, may butas na sa ilalim, nagli-leak na pala siya pero hindi nyo napapansin. So, that's systematic error, no? So, pwede mo pigilan yon. That could be determined. So, you can change your vol flask when using that, no? Pwedeng may leak yung burette, no? Remember yung burette, yung mahabang tube na ginagamit sa titration? You can use a new burette, no? To prevent that type of error. Malay mo kasi nagli-leak pa rin pala yun, no? So, palitan mo na lang. Okay? So, that's instrument error. Ano pa? One example would be yung effect ng voltage sa instrument, no? Kunwari ako, kapag gabi, papansin ko sa bahay, dito sa kwarto ko, pag gabi, yung ventilador, minsan malakas, tapos biglang hina, tapos biglang lalakas uli. Okay, what's the reason behind that? The alternating current, no? So our electrical supply is in AC, and that is converted to DC using motors sa ating devices, di ba? So, yung AC kasi natin, yung alternating current, it is fluctuating over time. So, tumataas, bumababa, tumataas, bumababa. And as a result, iba-iba yung voltage na ibibigay niya sa ating instruments. And the differing voltages of the electrical supply of our instrument could lead to errors, no? Pwedeng kunwari, biglang nagkaroon ng burst ng voltage, edi biglang magiging mataas yung mga reading ng instrument natin. That could happen, okay? Pwede naman biglang bumaba yung voltage, edi humina yung power ng ating instrument, so it will give us low measurements, no? So in order for us to resolve that, we use AVRs, no? Ano yung AVR? Automatic Voltage Regulators, no? Yan yung mga nasa desktop PC, yung pinipindot nyo bago yung computer system unit, 'di ba? So yung AVR, they maintain the same voltage supplied to your instrument so that your measurement will not be compromised by fluctuating voltages, okay? Ito ay common for spectrophotometers, no? For example, UVVs, no? Yung ultraviolet visible spectrophotometer, kapag biglang nagka-burst ng voltage diyan, liliwanag lalo yung light source niyan. So it could change the um, concentration reading or the absorbance reading of your sample. So it could compromise your results as well, okay? So in order for us to resolve that, pwede natin palitan yung instrument, pwede natin pwede natin siya bilhan ng AVR, or also we can calibrate the instrument then. So for example, pH meter. Ang pH meter, every time you use it, you have to calibrate it, no? So that it will give you accurate readings. Kasi there are people who do not calibrate the pH meter. Basta-basta na lang nila sinasawsaw sa liquid solutions nila. And no, that's wrong. Okay? So what you're going to do is that you have to calibrate the pH meter with different solutions, with different buffer solution, so that correct yung kanyang ibibigay na measurement, no? Kasi over time nawawala yung accuracy ng pH meter kapag hindi siya nakaka-calibrate, no? Excuse me. So ayun. So that's one way to resolve the instrument error. Calibrate mo siya. Pag hindi mo na talaga maayos yung instrument, bili ka ng bago kung mayaman ka na. Kasi ang problema, pag bibili ka ng bagong instrument, it will cost you a lot, no? Ang UVVs, 300,000 yon, pH meter, 15,000, no? Chromatography, 1 million, 3 million, no? So, kaya kapag kayo mag-a-analyze in the future, especially medtech kayo, ganun talaga buhay nyo, no? So, since yun yung buhay nyo, please check nyo kung may errors kayo, no? Kaya important ang stats kasi kapag marami kayong error, pwedeng masira yung instrument nyo. So, maganda na sa isang run pa lang ng experiment, tignan nyo na. Kung masyadong mataas ST-dev nyo, yung standard deviation, i-check nyo sino may mali. Baka yung instrument may problema na. Okay? Kasi kapag di nyo na-report yun, tas kayo yung huling gumamit, kayo yung magbabayad. Okay? Nangyayari yun kasi yung friend ko, nag-work siya sa, sa chemical company na nagte-test ng pharmaceuticals, no? Although hindi sa kanya nangyari, sa kasamahan niya. Nangyari daw is mali-mali na yung data na binibigay ng instrument. Kaso hindi niya ni-report. Tapos later on, sira na yung instrument pala, no? E di, nung tinignan yung logbook, siya yung friend niya yung huling gumamit. E di siya patuloy na reprimand, no? Siya pa yung napagsabihan na kung ano-ano, no? So, we don't want that to happen because it may destroy our reputation, no, as as medical technologists, as chemists, no. So we have to check, no, and we have to report kung anong types ng error yung mga pwedeng mag-arise sa ating measurements, okay? Para tayo, reliable pa rin tayo. Okay? Kasi kung hindi, sira yung reputation natin. Okay? So yun, so that's one type of error, one type of systematic error. We call that the instrument error. The next one is the method error. So there are chances na mali-mali yung data mo or spread out yung data mo because you use the wrong method. Okay? Katulad nga ng in-emphasize natin last time sa chapter 0, so you could still recall. And also, i-discuss din to sa chapter 2, I hope na-discuss na rin, that for every amount of your samples, there is a corresponding method for that. So iba yung method for macro analysis with the ultra trace analysis. You cannot use a method for all types of analysis, no, or all types of sample na meron ka. So iba yung methods mo kapag onti yung sample mo, iba yung methods kapag malaki yung sample mo. Okay? So if you use one method for all, then it will lead to a method error. No? Magkakos yan ng method error. Bakit? Kasi pwedeng maraming percent loss ka. Okay? So, kunwari, onti na nga sample mo, tapos ginamitan mo ng classical method, edi nawala na, wala ka nang na-detect. No? So, yun yung pangit. No? Method error tawag doon. So, what you want to do here to resolve the method error is to check, no? Ano ba yung aking ano ba yung sample size ko? What is the amount of may analyte in the solution? So pag nalaman mo kung ano yung sample size and yung concentration ng analyte mo sa solution, then pwede mo malaman kung ano yung corresponding na type of analysis na pwede mo gawin. Okay? Kaya nga, ang chemistry cookbook, makapal na book yun, no? Andun lahat ng pwede gawing analysis depending on the amount of your sample. So, merong recipe tawag namin doon eh. Merong procedure or recipe for grams. Merong recipe or procedure for ppm, no? Meron din for parts per billion. So, iba-iba siya ng process, iba-iba siya ng steps, okay? So you have to check whether your methods are correct or incorrect, no? So pwedeng chemical or physical behavior yung may mali eh. So check mo yung sample mo and yung method, no? So the two must be must be compatible to each other, okay? Kasi kung hindi sila compatible, mali-mali makukuha mong data. And the next one will be personal error. So this is a type of error that is personal. Ibig sabihin, ikaw na may mali. And we should accept that, no? There is no perfect person in the laboratory. Wala, no? Kahit yung gumawa ng analytical chemistry, di yan perfect. Yung gumawa ng libro na to, di yan perfect, no? Everyone commits error, no? For example, when we are measuring the lower meniscus, pwedeng nakaligtaan natin yung sinabi kong parallax error. Tumingin ka, nakayuko ka, nang tinignan mo yung meniscus. Personal error yon. Okay? Kunwari, tinitignan mo yung meniscus, tapos nakatingala ka, personal error uli yon. So, dapat kasi eye level. Ano pa yung mga types ng personal error? Pwede, nagtatitrate ka. Tapos, lumagpas ka na sa endpoint. O, yun, inattention yun. Hindi mo pinapansin yung ginagawa mo. So, you have to be very keen sa details, no, pagdating sa chemistry. Okay? And that can be, that can be resolved, no, by experience. Okay? So lahat tayo, if we gain more experience, then we can lessen the personal errors, no? Okay. Pwede rin naman because of physical limitations yan. Okay? So, kunwari, colorblind ka. Ito, nangyari to sa classmate ko, no? Colorblind siya, kaya tinutulungan namin minsan. So, colorblind siya and kailangan niya mag-distinguish ng color, especially pag titration. Kunwari sa amin, o kulay pink na yan, sa kanya, hindi pa rin pink yun. Edi yun, doon nagkakaroon ng errors. No? Kasi sa titration, didiscuss naman natin yun sa chapter 4. Ang endpoint ay pink. So, kapag pink na yon, hinto ka na. Okay. Kasi nangyayari, yung pink is, subjective eh. Di ba? Pwedeng yung pink sa akin, colorless pa sa'yo. Kaya yung pink na pink sa akin, sa'yo, pink pa lang. No? So, subjective siya. So, kailangan may tutulong sa isa't isa. No? Especially if may color blind. No? Okay? Pag may color blindness sa red. No? So, yun. So, again, personal errors can be eliminated by experience. No? Kailangan marami kang experience muna until you gain enough knowledge and enough skills so that you will not commit any wrongs again kapag nagme-measure ka. Or pwede naman because of limitation mo na siya. Meron kang disease or condition na hindi na talaga masusolusyonan with other stuff. So you need to ask help, no? And that's normal. Pag nasa laboratory kayo, you will always ask help sa inyong peers, okay? So just be friendly lang, okay? So ganun. Yan yung mga types ng error that we can encounter sa laboratory. So again, pag medyo lumalaki na yung standard deviation mo, then you should be cautious. You should consider whether yan ay may systematic error na or wala. No? So again, ano yung mga types of systematic error? Instrument error, these are the errors because of the instrument and they can be resolved by buying voltage regulators, calibrating your instrument, or kapag wala na talagang pag-asa, you buy another one. Okay? Second one is the method error. That is because yung iyong sample hindi siya compatible with the method. That's why you come up with false results, no, or bad results. So whenever you are doing chemical analysis, no, your method should be compatible with your sample and the sample size. Okay? So for each sample size kasi iba-iba yung types of analysis na ginagawa. And then last one is the personal error. So these are errors that are caused by the analyst, no. So yung tao na may mali dito. And this could be resolved, no. Just just acknowledge na ikaw pwede ka magkamali, no. Okay. So kahit gaano pa man kataas yung napag-aralan mo, kahit top-notcher ka man o hindi, no. Malaki sweldo mo o hindi, lahat tayo nagkakaroon ng errors, no. So we should accept that, no. And we can ask for help naman sa ating peers in the laboratory so that we can minimize the personal error. Kasi if we disregard this, masisira lalo reputation natin. Okay? And then the last one is the gross error. Ito yung pinakamalala kasi gross nga siya. So ito yung super duper layo na ng nakukuha mong values. No? So, one of the reason bakit may gross error is the gross negligence, no. So, napabaya mo na talaga yung measurement mo. Kunwari, hindi mo tinignan na maayos, nagkamali ka ng basa. Kunwari, dito sa temperature, kunwari, 31 degrees siya, pero nakita mo, 29 degrees. No? Tapos hindi ka na nag-second look, no? So, gross error yon. O kunwari naman, you are doing titration, tapos pagka ganun mo ng yung handle sa dulo, pagka ganun mo, biglang nabasag, natapon lahat, sinayaan mo lang. So, that's gross error, no? So, whenever we have gross errors, they lead to outliers, no? Discuss natin mamaya yung outliers, okay? So, in summary, ito yung types ng error, description, and yung solution. So when we have random errors, that's okay. That is something innate with measurements. Andiyan na yan. wala tayong magagawa, no, to resolve that. Okay? Wait lang. May nag-email lang. Okay? So, yan, random errors. There are innate. Andyan na yan. So, there's nothing to do. No? Andyan na yan eh. So, pero ang pwede natin i-focus ay yung mga pwede pa i-resolve, no? Such as the systematic and the gross error. So, for systematic, they are determinate and they can be corrected. No? So, pwede mo malaman, pwede mo ayusin. Okay? So, ang solution natin dyan, you can use standards, calibration techniques, no? Etc. No? And then lastly, yung pinaka-bad is yung gross error. Okay? So, ito yung pinakamaling-mali, no? Ito na yung maling-mali talaga sa lahat ng mali, no? So, it also leads to outliers, no? So, when you say outliers, these are data that are far from your usual result, no? Kunwari yung data mo, magkakadikit, tas yung isa, super layo, gross error yon. Okay? That is an outlier. Okay? Although there is a statistical tool that we can use, no, to check whether your data is an outlier or not, no. Malay mo kasi hindi naman pala siya outlier. Mamaya kukwento natin how to determine outliers, ha? Okay. So however, if you have gross errors talaga and if you determine talaga statistically na outlier 'yon, you have to repeat your process. Ulit ka ulit from the top. Okay? So, nangyayari yan. And ako, I actually experienced those errors. No? Lahat ng errors na yan, experience ko yan. No? Kasi, pag chemist ka, you live your 4 years in the lab. No? Undergrad, 4 years kang nasa lab. First sem, second sem, minsan may summer sem ka, nasa lab ka. Yun. Pagdating mo ng work, nag-academe ako, pero nasa lab din ako minsan, no? Doing chemical experiments with my students, no? So, yun. Over time, you will develop the skills naman. Pero kapag nag-uumpisa ka pa lang, you will commit all those types of error, no? So, nagawa ko rin yan lahat, no? Especially yung gross error. So, pwede naman ma-resolve yan, okay? Just be cautious na lang next time, okay? So, yan. Important to, especially sa ating work ethics, ha. So kapag na-consider mo yung types ng error na pwede mag-arise, then you can be better, okay? Kasi kapag hindi mo ni-recognize yung mga yan, wala, masisira lang yung name mo, okay? So important to, especially kapag nag-work na kayo, ha. So yan. Okay, so balik ulit tayo sa statistics. Let's talk about standard deviation first, no? So, we say na yung standard deviation, this is a measure that helps us determine whether your data points are spread out or not, no? So, titignan natin kung kalat yung data or not. Kasi depending on the spreadness of data, it could tell us whether you have random error lang, which is okay lang. Pag masyadong spread out yung data na, you can have systematic errors. And kapag super spread out yung data, it is possible na may outlier ka. Hence, you have gross error. Okay? So, standard deviation is very important. No? Hindi lang siya number. Hindi lang siya grades is just a number. No? Hindi lang siya basta-bastang number. This could help us to see whether may mali or wala. Okay? Or normal lang yung error. Okay? So, in order for us to solve for the standard deviation, we solve it as S, or the standard deviation, equal to the square root of the sum of x minus x bar square divided by n minus 1. So, ano meaning nun? So, etong sum of x minus x bar, x means our data, minus x bar, meaning yung average. So, kukunin natin difference ng data and the average. Isa-square natin yun, then i-add natin lahat. That's why we have the summation symbol here. And then later on, we will divide it by n minus 1. Mamaya, gamitin natin yun. Don't worry. Paki-copy na lang muna yung equation sa notebook niya. Okay. So, gamitin natin mamaya yan, ha? Okay, so tuturo ko sa inyo yan. Okay. The other measure for the spreadness of data with 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 regards to the mean, no, is the relative standard deviation. No? It checks whether uh, it checks the proportion pala. It checks the proportion of your standard deviation with the mean. So kapag malaki yung RSD mo, that means super off na ng data mo. Okay? And minsan may sineset na standard dito. For example, the 0.05 or the 5% RSD. Minsan hanggang doon lang limit, no? So if you have RSD greater than 0.05, then pwedeng may systematic error or gross error na. Pero anything lower than that, okay pa lang, no? So may sineset doon, no? Pero hindi muna natin gagamitin yung RSD for now. Okay? So we are focused on the standard deviation. Okay? So let's have this, for example. Okay, so ito yung mean, ito yung data na ginamit natin kanina pa. So what you're going to do if you're solving for the standard deviation is you create a table. You create a table wherein you may column for x. Actually, dapat may column for x bar then x minus x bar. That means the measurement minus your mean. And then later on, you will square it. Then after squaring all the x minus x bars here, you're going to add them up to get the sum of x minus x bar. This will be used as the numerator for our standard deviation calculation. Okay. So mamaya may practice tayo dito. Okay. Leave that hanging na lang muna. Okay. So after that, since na-solve mo na yung sum of x minus x bar square, you will plug it in this standard deviation formula. Then n minus 1, the number of measurements minus 1. So solve mo lang yan using calculator, you will get your standard def na. Pag masyadong mataas yan, magduda ka na. Kapag hindi yan mataas, okay lang na. So yan. For example, ito. The RSD is below 0.05. So ibig sabihin, okay pa to. Okay pa yung data na yan. Okay? So medyo okay pa yung data mo na yan. Pero kapag lumaki pa yan sa 0.05, then may na yan, meron something na dyan sa measurement mo. Again, yung 0.05, yun ay convention lang sa statistics. No? You can change that. No? Pwedeng mas strict ka. So, pwedeng 0.03. Pwede namang mas maluwag ka. Pwedeng 0.01. So, yan. Pwedeng 10%, 5%, 3%. Yung yung problem na bahala dyan magsabi kung ano yung acceptable value. Okay? So, ganun lang. And kunwari, malaki na talaga standard deviation mo, kasi super laki, no? Medyo kaduda-duda na. Then, you must check whether may outlier ka or wala, no? So, when checking for outlier, this is statistical tool can be used, the Grubs Test. Actually, dalawa yan. Q-test din yung isa. Okay? Q-test. Q-test talaga tawag sa kanya. Okay? So, ginagamit ko, ito favorite ko Q-test kasi madali lang formula. Pero ito yung nasa PowerPoint, so ito gamitin natin. Ito yung nasa book eh. So, let's use Grubs Test, no? So Grubs Test and Q-test, these are tools when checking for outliers, no? Okay, so bali ganito mangyayari. For you to solve the Grubs test, that can be calculated as this equation. So you have the absolute value of your questionable value minus x bar divided by your standard deviation. Okay? So ano yung questionable value? This is the value na kine-question mo whether siya ay outlier or not. No? And usually, sila yung mga nasa dulo ng measurement. So, sila yung pwedeng nasa pinakauna or pinakadulo. Because yung nasa gitna, hindi sila magiging outlier if one dimension lang yung iyong data. Okay? So, sa ngayon, one dimension lang naman tayo. Hindi pa tayo nagre-regression analysis. No? Okay? Kasi hindi naman natin gagawin yan sa biostats nyo na yun. Okay? So, again, kapag outlier, to check mo yung pinakauna and pinakadulong data if you have one dimension data points, no? Pero kapag may x and y axis na yan, then iba na yung treatment doon. Gagamit ka na ng Pearson stuff, no? mga linearity stuff. Basta yun. Sa biostats nyo na yun. Okay? So, yun. You will assign your questionable value kung sino fill yung outlier. Yun, then you subtract it with the average. You will get the absolute value, so the value will be positive. Divide it by standard deviation. So kung ano yung makalculate yung G value, you're going to compare it with the tabulated G value. Okay? So the tabulated G value will help us whether we can reject the outlier or accept it. Ibig sabihin, pwede natin to gamitin to see kung tatanggalin natin yung outlier, yung suspected value mo, or we could retain it and hindi siya outlier. Okay? So what you're going to do is you compare your G calculated with the G tabulated here. Itong nasa table. So pagka-compare mo na yan, if your G calculated is greater than the tabulated, that means lagpas na siya sa threshold, then the outlier is confirmed. No? Confirmed na outlier siya and it should be discarded. You have to remove that data point. No? However, if your G calculated is less than your tabulated, then hindi siya outlier and it should be retained. Okay? Andyan talaga dapat siya. Huwag mo siya buburahin. Okay? So, ganun yung purpose ng Grubs test. Again, the formula for a Grubs test is Q, the questionable value minus the average divided by the standard deviation. Okay? After you solve the G calculated, you compare it with the G tabulated here. Okay, so kung gusto niyo screenshot yan, go lang. Kung may copy na kayo ng PowerPoint, go lang din ulit. So you're going to compare your G calculated with the G tabulated. And if ang G calculated exceeds whatever is written here sa table natin, then that is an outlier and you must reject it. Burahin mo siya. Okay? Pero kung hindi siya lalagpas dito, maintain mo lang siya, remain mo lang, okay? So for every number of observation, there is a corresponding G value, okay? For 9 measurements, ito lang yung pwede hanggang dito lang yung pwedeng G. For 12 measurements, hanggang dyan lang yung pwedeng value for G, okay? So ganun. Pag lumagpas dito, mali na agad na outlier na 'yon. Okay? So this is one example here. Okay, so suppose we have this measurement. Okay, so may 12 data points tayo. So hanapin daw natin if there is an outlier or not, no? So ang usual na ginagawa namin dito is you arrange your data points from lowest to highest so that you will see the lower end and the upper end, no? Okay, so kung titignan mo tong number na to, the lower end is 7.8, no? Which is quite weird. Why? Kasi the other points are 10, 11, and 9. Pero yung 7, isa lang yon, no? Ito lang yon, 7.8. So that means this number is fishy, no? Medyo kaduda-duda siya. So in order for you to check whether that is an outlier or not, you have to employ the use of Grubs test. So Grubs test can be computed as G calculated equals questionable number minus the average, get their absolute value, and then divide it by the standard deviation, which was already calculated. Okay? So, pa-plug in mo lang yan. You have your questionable number minus the average divided by the standard deviation, and then we solve for the G calculated being equal to 2.13. After solving for the G value, we compare it with the table for 12 observations. So according to table, the acceptable G value is 2.285. So that means anything lower than that is okay. For our case, G calculated is lower than the G tabulated. So that means 7.8 is not an outlier and it should be retained. Pag lumagpas dito sa 2.285, outlier na yon, and you should remove that data point, okay? So that bababa yung standard deviation mo, okay? So ganun lang. So that's how we use statistics, no, to improve the reliability of our results, no? Because if ang ating result ay unreliable, it could bring us down. Sa totoo lang. So, it could bring your name down. Kasi yung mga companies na ina-applyan nyo, nagkukwento-kwento yan talaga sa iba't ibang companies din. Parang they have this database of people who work with them and yung mga ginawa nila. So that's true. No? Okay, so yan. So anyway, so again, statistics is important in chemistry because it could help us to address the common issues in the laboratory, no? Whether may errors ka or wala, and how to improve your methods in taking measurements. Okay? So makakatulong to sa atin. So we're done with the PowerPoint. So pwede natin yun set aside. So let's go to our worksheet. So please bring out your calculator with you. I hope you have your worksheet opened na. So let's solve for this one item here. Yung isa, kayo na bahala dyan. Okay? Iwan ko na yan sa inyo. So basahin natin yung kanyang instruction. From the set of data below, 1. Solve for the mean, median, mode, standard deviation. Number 2. Identify whether there is an outlier. If so, solve for the mean, median, mode, standard dev if the outlier is to be eliminated. Okay? So, ganito gagawin natin. Solve for the mean, median, mode, STDev, standard deviation. If may outlier daw, check mo. Kung meron, tanggalin mo siya. Then, you solve for the new mean, median, mode, and standard deviation kung wala yung outlier. Okay? So, let's solve for this item here. We have the water hardness profile in ppm or milligram per liter. And we have 10 data points here. So we have 325, 396, 345, 336, 384, 305, 396, 328, 384, and 357. Okay, so we have 10 data points here. What we're going to do is to get their average, no? Para makuha yung mean, no? Pero bago na tayo pumunta doon, gamitin na natin yung table. So this table has columns for X. That means yung individual measurements natin. It also has column for X bar, which represents the mean. So kakopy mo lang yung mean mo. Then you have X minus X bar, which means the difference between your X and the mean. And then the last column is the square of that difference. Okay? So, ano unang gagawin natin? Let us arrange our data points from lowest to highest. Okay? So, maglo-lowest to highest tayo. So, arrange ko lang to ha. So, lowest would be 305. You do your thing. I do my thing din. Tignan ko yung mga numbers eh. Susunod would be 325. Okay, so I already arranged my data points, no? May copy ako dito. So I already arranged my data points from lowest to highest. Okay, so yun yung una mong gagawin. Next, so you can solve for the mean, median, mode na. Okay, so solve muna natin yung mean. So when solving for mean, you want to get the sum of your x first, no? I-add muna natin sila lahat. So add natin. Mag-solve din kayo ha. Okay? So the sum is, paki-check kung pares tayo ng figures, ha? That will be 352.9. Okay. Hopefully, yan din nakuha nyo. Okay? So the sum of all the value of x is 352. Ay, 3529 pala. Average na yung binigay ko. So that's 3529. So we can now solve for the mean. So again, the equation for mean will be the sum of x divided by n. So that will be 3529 divided by 10 since we have 10 measurements. So the mean will be 352.9 ppm. Okay? So yun yung mean. Next one, median. So look at the data points that we have here. So to get the median, we're going to check the middle value. So ilang kaya yung middle value natin dito? Since this is an even number measurement, 10 measurements to, meaning nun, dalawa yung nasa gitna natin. So let's check. No? Are we going to check for the median? You cancel out the outer numbers first until you are left with the middle numbers. No? So cancel natin yan. Cancel this. Cancel that. Lahat na i-cancel mo except for the two middle values. No? Kapag odd number to, isa lang matitira. Pero kapag even number, dalawa matitira sa gitna. So how do we solve for the median if dalawa yan? So to solve for the median, you get the average. No? So median, that is the average, 345 plus 357 divided by 2. That will be 351. Okay, so that's the middle point of all the measurements, 351. And so we're done. Malapit na tayo matapos. Okay. What's next? Mean, median, and mode. When you say mode, this is the number that is frequently repeated sa ating measurement. So by just observing them, obvious naman that 384 will be our mode kasi it is the only number repeated twice, di ba? So siya na yung mode, no? 384. Okay, so yan, we get the central tendencies na. Mean, median, mode, no? So yan. The next one, let's solve for the standard deviation. So in order for us to solve for the standard deviation, we have to use this table, okay? Because the formula for standard dev is s equal to the square root of the sum of x minus x bar squared divided by n minus 1. So we have to look for this value muna, okay? So let's solve for that value using the table, okay? So yan. So we have the table. Column 1 is already filled with the value of x. Next one, we're going to write the x bar, the average. Okay? So pwedeng wala ng x bar column, no? Kasi alam mo naman na yung x bar, no, yung average. Pwedeng i-minus mo na lang automatically, no. Pero mas gusto ko nilalagay siya para makikita mo kung ano yung isusubtract mo. Okay? Baka kasi mamaya makalimutan mo. Kaya I place this column here. Pero sometimes kahit wala na yan, okay lang. So, ayan. Sulat natin yung average, 352.9. Okay, so yan, we have the X bar in the second column. Kokopyahin mo lang lahat yan. Then, on the third column, you have the x minus x bar. So you're going to subtract 305 with 352.9, 328 with 352.9, so on and so forth. So I want you to solve this, no? Solve ko rin to. So, sagutan ko muna, okay? So, sagutin kaya. Okay, so hopefully nasagutan nyo na rin. So we have the values for x minus x bar here. So yan na yan. Sana yan din nakuha nyo. So what's next? We solve for the x minus x bar squared. Okay. So what you're going to do here is just to square what's in the third column. And when you square the numbers in the third column, all the negative numbers will be eliminated. No? Kasi negative number, pag in-square mo yon, that means multiplying the negative number by a negative number. So, magiging positive yon. Okay? So, basically, the last column will be positive in value. Ha? So, let me solve it. Solve din kayo. Okay? So, wait lang. Okay, so hopefully tama yung mga na-solve natin. So I already have the column 4 filled out. No? So basically what we did is that whatever is written in your third column, just square them. Okay, so in-square na natin sila doon. Okay na tayo doon. Okay, so what's next? Remember the formula for standard deviation. It requires the sum of x minus x bar squared. So that means for the last column, we're going to add them so we can get the sum of the x minus x bar squared. So i-add na natin lahat ng nasa last column. Okay? So give me some time then. Sagot din kayo ha. Add ko lang to. Okay, so hopefully you came up with the same answer. So the sum of x minus x bar is 8,108.9. Okay, so sana yan din nakuha niyong answer. So since we have the sum of x minus x bar na, daming ginawa, no? Yan lang pala kailangan natin. So since we have that already, we can now solve for the standard deviation. So in solving for the standard deviation, that is s equal to the square root of the sum. Ang pangit ng summation ko, wait lang. The sum of x minus x bar squared divided by n minus 1. Okay, so what is the sum of the x minus x bar squared? That will be 8,108.9, and that is going to be divided by n minus 1. So what is n? 10. Kasi we have 10 measurements minus 1. Okay? So, pindot uli sa calcu. And let us round it off to 2 decimal places. No? Okay. So the answer will be 30.02 into decimal places, no. Pero ang nakalagay sa calcu ay 30.01647.696, no. So if you came up with that answer, then tama yung sagot natin. Okay? So that's how we solve for the standard deviation, no. Ang daming ginagawa, no? Yes. Kaya nga, stick around lang kasi I will teach you the calculator technique when solving for the standard deviation and how to do this in Excel. No? Okay? So, yan. Yan. So, kung gusto niyo screenshot, go lang. Although, pwede nyo naman panoorin ulit sa YouTube. Okay, so let's proceed with number 2. Sabi doon, determine if there is an outlier. Okay, so how will you determine kung may outlier? We can use the Grubs test. Dito tayo sa right side. So again, what's the formula for the Grubs test? G calculated is equal to the absolute value of the questionable value minus the average, and they will be divided by the standard deviation. Diba? Question, ano ba yung questionable value ko? Ikaw mag-a-assign. The reason why we arrange the number from lowest to highest is that we can check whether the lower end or the upper end is an outlier. Okay? So, pwede natin tignan kung yung pinakauna or yung pinakandulong number ay outlier by arranging them increasingly. No? So, sino gusto nyo muna i-test? So, si 305 muna, di ba? So, 305 kasi tignan mo, oh, siya lang yung zero. Tapos yung iba, may number na. Baka outlier siya. Baka lang. Tignan natin. So, let us assume that 305 is an outlier. So, we have to use the Grubs test to check that. So, our questionable value would be 305 minus the average, which is 359.2. Tama ba? Okay, so tama. 359.2 divided by your standard deviation, which is 30.02. Let me solve lang, ha. So that will be 1.805. Okay, so the G calculated if your 305 will be your questionable value is 1.805. Ano susunod na gagawin? Compare G-calc with the G tabulated. Okay, so kapag G tabulated na, tingin tayo sa table. Balik ulit tayo dito sa table. Ito. Paki-screenshot na. Ayan. So this is the table. This is the table that we can use to determine the value of G tabulated for a certain number of observation. Okay. So since we have 10 measurements here sa ating problem, so our G tabulated will be equal to 2.176. Okay. Yan. So yan. Thank you. Thank you, Raf. Yan. Save nyo na yan sa phone nyo. Okay. So since we have 10 measurements, then our G value must be 2176. Hanggang dyan lang yung limit. So let us compare that with our G calculated. Ano yun? 2176, di ba? Okay, so our G tabulated is up to 2.176. So the last thing you're going to do is to compare the G calc and the G tab. Sino mas malaki? At 352.9 ba? Sorry. Thank you. So mali din ta. 352.9. Okay? Compute ko lang ulit. Thank you for that. 352.9. Ayun, okay. Kaya pala parang nagtataka ko. Ilang beses ko na to inulit, tas ba't nag-iba yung Gcalc? Mali pala ng minsa. Thank you. Ayun. So, our G calculated will be 1.596. Okay? And the G tabulated will be 2.176. Ngayon, sino yung mas malaki? Yung G tab. So, since G tab is greater than our G calculated, that means 305 is not an outlier. And we should retain it, Retain it, Okay? So, yan. You can take screenshot. So, ganun lang. So, pag nakita nyo yung G calculated nyo less than the G tabulated, so, yan? Hindi yan outlier. Pero kapag mas malaki yung G calculated mo sa G tabulated mo, outlier yan. And you should remove it. Okay? Sir, paano kapag equal sila? Retain mo pa rin. Okay? Kasi hanggang dun lang. Hanggang G-tab lang yung value. Pag same lang sila ng value, pasok pa rin. Pero kapag lumagpas na onte, hindi na siya pasok. Burahin mo na siya. Outlier kasi siya. Okay? So, ganun lang. We can use RSD. Okay, ito. We can use RSD to check kung ano yung relative standard deviation natin to the mean, So to solve for RSD, that is just S divided by the X bar, diba? So our standard deviation is 3002 divided by the mean, which is 352.9. Tama na. Okay, so 352.9. Okay. So check natin kung ano yung RSD natin. So that will be 0.085. So medyo lagpas siya. Kunwari, ako ay analyst, tapos ang threshold ko ay 0.05 or 5% lang. So ito medyo mataas pa yung aking RSD, So possible I have systematic error dito. Okay? So ganun natin conclude, So pwedeng may systematic error, pero ang mahalaga wala akong gross error. Okay? Wala akong gross error kasi walang outlier. So kapag ganun, sasabihin ko, if the RSD is set to be 5% or 0.05, tignan mo kung ano yung RSD mo. Then kapag pasok siya dun sa RSD mo, then okay ka. Pero kapag medyo mataas siya onte, then mayroong systematic error dyan, no? So, I don't know kung saan nanggaling yung error kasi data lang binigay sa atin. Okay? However, if you are doing the actual experiment, you can infer naman kung saan ba galing yung error ko. Okay? So, galing ba siya sa instrument, galing ba siya sa method ko, or sa akin na mismo. Okay? So, ganun. That's how we interpret statistical tools with our lab ano with our lab outputs, no, and our performance sa laboratory. Okay? So pag nag-work kayo sa industry, you will be tested always, no? Yearly. Ito-test kayo sa inyong accuracy and precision. So tandaan nyo lang, may statistics na ginagamit para matest kayo. Okay? So keep that in mind, no? So yun lang. So that will be our lesson for this day. Pero, di pa tayo tapos. So, tinuro ko na sa inyo yung long method. So, this is the long method. Lahat na pinindot natin sa Calcu. So on and so forth. I will teach you the two other methods. Okay? Na pwede nyo gamitin pag nagku-quiz kayo or exam o kaya in real life. Okay? So, turuan ko kayo paano mag-calculator technique. Okay? So, let me open my camera para makita nyo yung pinagagawa ko. Ayan, say hello na lang. Makita nyo yung sarili nyong picture dyan. Okay? So, if your calculator is, tignan nyo yung model, Casio 991 ES Plus, Casio 991 ES, Casio 570 ES Plus, Casio 570 ES, Casio Class Swiss, ES and EX 991 something. Pag yun yung version ng calculator nyo, this will work, no? However, if ang calculator nyo ay Sharp or other brands, I don't know how it works, no? Kasi Casio talaga yung preferred sa amin, no? Sa chemistry. Kaya panalo sila pag nagbebenta sila ng calcio sa classroom namin. Okay? Ito kasi yung preferred talaga sa chemistry. Okay? Even sa board exam. Okay? Luma na tong calcio na to, no? So kasama ko siya since 2014. Sa hirap at ginhawa, buhay pa rin siya. Okay. Pinapalitan ko lang ng battery sa likod. Okay, so we are going to use this calculator in order to solve for the standard deviation. Pwede rin yung mean, okay? So paano 'yon? Okay. So just go to the mode. Pindutin mo yung mode. Kamali pa ng tusok. Just press the mode, you will be given with this menu. You have the complex, the stat, the base n, equation, matrix, table, vector. Okay? So, yung complex, yan yung mga complex numbers, yung may mga, I, no? So, if you're familiar with that complex number, yung I, di ba, I square equals -1. So, complex number yon. Diyan yung gagamitin mo. Number 3 is statistics. Ito yung gagamitin natin. 4 is the base n. That means this is focused on logarithmic functions. 5, equation. Magagamit natin yan sa titration. We can use, di ba, kapag nagka-quadratic equation tayo, we solve for the value of x, no, using quadratic equation. So, yun. Pwede natin i-calculate din yun. Ituturo ko rin yun sa inyo. Don't worry. Number 6 is the matrix. Ayan yung mga square-square na may numbers sa gitna. Okay? Ginagamit yan sa physics and chem. 7 is table. Table. Then 8 is vector. Yan yung ginagamit ng mga physics. No? So, ang gagamitin natin for this SEM is yung stat and equation. So, yung stat, tuturo ko ngayon. Yung equation, tuturo ko sa susunod na chapters. No? So, let's press 3 for stat. No? Then you are given with another set of menu, no? So we have one var, meaning yan, one variable. So yan yung gagamitin natin. Bakit? Isa lang yung variable natin. We only have the value for x. Okay? Isang data point lang meron tayo for each measurement. Number 2 is a plus bx, that is used for regression analysis. That is if you want to establish an equation for the line or the calibration curve. No? However, we're not going to use that. Okay. Pero if you want to establish the calibration curves, we use a plus bx. Kasi that is equal to the slope of the point slope form, no, ng ating line. Number 3 is something plus cx square. So that is for quadratic equation. Number 4 is for logarithmic function. 5 is for exponential functions. 6, 7 is for exponential functions then, na iba yung base and iba yung exponent. And then 8, we have, excuse me, and for 8, we have the inverse function of x. So basically, that's 1 over x lang. So, anong gagamitin natin sa lahat ng to? For now, one variable lang. Okay? So, one variable kasi isa lang value meron tayo. Value of x lang. So, you press 1. Dami sinabi, no? Okay. So, mapapansin mo, this table actually is something similar with yun nasa worksheet natin, no? So, yung worksheet natin, we have this table for x bar, x minus x bar, x minus x bar square. Sa calculator, ang meron lang ay yung x kasi siya na yung bahala sa iba. Okay? Siya na yung bahala mag-solve for the others. Okay? Excuse me. So, gagawin natin dito is, teka lang, isa natin yung autofocus para maliwanag yan. So, gagawin natin is that we're going to plug in our data points inside the table. So, paano yan? You just type in the number. Type ko lang, 325. Ay, nawala. Type natin, 325. So, you press 325. And then, press equal sign so that that number will be inside the cell na. So, you press equal sign. Okay? So, andun na yung 325. Do that for the remaining 9 measurements. Okay? So, press ko lang. Excuse me. So, yan. I already plugged in the 10 digits. 325, 396, 345, 336, 384, 305, 369, 328, 384, and 357. If you happen to type the wrong number, you can overwrite it. So just select the cell, then retype the number. Retype lang natin, then press equal sign. Okay, so pwede mo ma-overwrite siya, or you can just press the del button, the delete button. Okay, so ganun lang. Okay, so once you plugged in all the data points that we have here, pindutin mo yung on. Wala na. Ayun, tapos na. Yun na yun. Hindi, joke lang. So, kung gagawin nyo, to access the results ng statistical tools natin dito, di ba, may kita nyo sa baba ng calculator nyo, meron nakalagay doon na stat, no? Sa number 1. Yun, may yellow na stat. So, in order for you to access that, press shift, then stat. Okay. So, pagka-press mo ng shift, then stat, you will be given with this option here. Type, data sum, variance, distribution, and min-max. So what we want is the variance. No? If you want to edit your table, just press data, babalik kayo sa table. Doon kayo pwede uli mag-edit. No? If you want to get the sum, itong sum, yan, kung gusto mo kung yung x square, x lang, you can do that. No? So, pero ang focus natin ngayon would be the var or the variance. No? Okay. So, pindutin mo yung var, you will be given with 4 options, no? One is n. N is the number of measurements, which we know is 10. So, huwag mo na pindutin yan. Next one is the x bar, which is the average. And then for 3 and 4, we have the standard deviation. Ano yung difference ng dalawa? Etong sigma x, no, for number 3, that is the population standard deviation. And the formula is different with what we use. No? So magkaiba siya ng formula sa ginamit natin. So hindi natin to gagamitin. Kasi magkaiba yung standard deviation formula if onti lang yung data mo and kapag super dami ng data mo. Okay? So, yan. So, hindi natin to gagamitin. We will use the SX. Okay. So, the SX is the standard deviation that we use, no? Yung formula na ginamit natin, yun yung ginagamit din niya. So, ang pwede mo gamitin dito is yung 2 and 4. The X bar and the SX. Okay. So, check natin. Kunwari, X bar. Ano yung X bar natin? 352.9. So, you press 2. Ayan. Nakalagay X bar. Okay, para lumabas yung sagot, you press the equal sign uli. Okay, so yan, nakalagay 352.9. So that is the average of our data points. Okay, so ganun lang, easy. Di ba pwede ito kapag nagku-quiz kayo or nag-e-exam kayo, ha? Pwede nyo gamitin yan pag ganun. Kasi ako, yan talaga gagamitin mo. Mas sa board exam, pag may stat doon, you better buy Casio. Okay. Hindi ako nagpa-promote kasi ito talaga yung pinaka ginagamit. Okay. So yan. So that's how we solve X bar using the stat function. Ngayon naman, let's check the standard deviation. So again, you press the shift, then 1. Then you press the var, yung variance. And then you press 4 again for the SX. SX is the standard deviation. Ano yung standard dev natin? 30.02. Pero yung complete form nun ay 30.016 something something. So, tignan natin kung yun din lalabas dito. Ayun, yun din yung lumabas. 30.016 something something. Okay? So, that's the shortcut number 2. Yung number 1, yung long cut. Well, long cut, ibig sabihin, solve mo talaga siya manually using this table here. This is the shortcut na itong method 2 natin using the calculator. Okay? You will find that very helpful kapag kayo ay mag-quiz, no? So, if your calculator can do stat function, magpasalamat kayo sa sa may kapal, no? Pero kung hindi, you have to do it manually pa. Okay? So, ganun lang. So, yan. Last one. Let's use Excel. Close ko na to. Okay? So, last one will be Excel. By the way, important na kapag kayo nag-work, alam nyo dapat gumamit ng Excel. How to graph, how to use the stat functions of your Excel, etc. No? So, naging na siya, requirement na sa trabaho. No? Kasi lahat ngayon Excel na. Okay. Nag-aral ka ng sobrang tagal para sa manual solving. Pagdating nyo sa trabaho, Excel lang gagawin nyo. That's life, no? Welcome to the corporate world. Okay. So, gawin natin yan. Okay, so we have the Excel here. I'm going to plot the numbers that we use. So we have dito na lang X. So type ko lang lahat ha. Okay, so we have 325, 396, 345, 336, 384, 305, 369, 328, 384, 357. Okay, so that is the value of X now. So, kung gusto nyo, yung mabilisan talaga, you can solve for the X bar and the STDEV. No? standard deviation of this number. Paano? So, ganito lang. Equal sign. Equal sign. Para makuha mo yung x bar or the average, just type equal sign followed by average. Open parenthesis. You select your data. Okay, so yun yung pwede mo gawin. Then enter. Yan, 352.9. Okay, so again, to solve for the x bar, that's equal average. Open parenthesis. Select your data set. Press enter. 352.9. Yan. To solve for the standard deviation naman, that is equal sign stdev. That's why I call standard deviation stdev kasi sa Excel, stdev tawag sa kanya. So, stdev lang. Huwag nyo napansinin yung mga eme dyan. Okay? So, just type stdev, then open parenthesis. Select your data set. Enter. 30,0165. Or kapag na-round off mo yan, 30,02. Yan din yung nakuha natin. Okay? So, ayan. So, that's X bar and stdev na something. Kunwari, gusto mo naman sagutan yung worksheet natin nang hindi nagma-manual solving. Diba? Mag-fill out kayo ng table dito. And you have this table, that table, that table. Kung gusto mo yung masagutan ng mabilisan, you can use Excel. Okay? So sabi nga nila, it's not about working hard, no. It's about working smart. Okay? Kaya ako, I give you options, just work smart, okay? So ganun. So, kasi pag nag-work na kayo, yung onting time na nauubos ay pera ang kapalit, no. So ganun kasi yung tingin ng corporate world sa oras, no. That's money. So that's why you have to work efficiently and smart, no. So kunwari, you want to fill out this table sa worksheet natin, pero tinatamad kayo mag-solve or ang bagal ng calcu nyo magsagot, yung calcu pa talaga sinisa, no? You can use Excel naman. Okay? So type mo lang dyan, x bar, x minus x bar, followed by x minus x bar squared. Okay? So x bar, what is x bar? That's 359.2. So we can copy that. Okay, copy mo yan. Then paste mo siya as a number. Ayan. Click mo lang yung clipboard, then yung paste may drop down siya. You paste it as value lang. Para number lang yung mapupunta doon. And then for you to copy it all the way down, you put your cursor dito sa lower right side ng inyong cell. Tapos magiging manipis siyang cross, and then you double click it. Okay? Kung ayaw mo i-double click, gusto mo pinaghihirapan, edi i-drag mo. So, ganun. Okay? Next one, we have the x minus x bar. So, that's equal sign. Select the cell for your x. And select the cell for your x bar. Okay? And then, enter. Diba? Yan din yung sinolve natin. And then, if you want the equation to be carried over to the other cells here below, you can double click this part of the cell. Kapag naging thin na yung cursor mo. Double click mo lang yan, the equation will be carried down. So, ayan. And then, lastly, for you to square this column, ano gagawin mo? So, you press equal sign, you select the cell, and then, paano mo i-square yan? You press sa inyong, sa inyong computer, yung symbol na yan. I don't know what this is called, pero yan, yung triangle na pataas. Okay? So, i-square niya yung value niya yan eh. Yan. So, raise to 2. Press enter, and then again, double click to copy the equation. And then, di ba ang kailangan natin sa stdev ay sum. So, you type muna sum x minus x bar squared. So, para makuha mo yung sum ng column na to, you type in equal sign, followed by the word sum, and then select your data points, and then press enter. Yun din yung na-solve natin, di ba? O, di ba? Bilis, di ba? Kaya nga, it's not about working hard, no? It's about working smart. Okay, so yan. So, ganun lang. So, again, that will be equal sign, sum, open parenthesis, select your data points, enter. Okay. Okay. So, by the way, tignan, gusto ko explore nyo muna yung Excel nyo, ha? I'll be back. May nagdo-doorbell lang. Okay, so wait lang. Okay, anyway, going back. So, ayan, kunwari nakuha mo na x minus, yung sum ng x minus x bar squared. To solve for the standard deviation, ningal ako dun ah. STDev, kung ayaw mo na ganito, gusto mo yung ano, yung equation gamitin natin. So, you type in equal sign SQRT open parenthesis. So, ganun gagawin nyo ha. Equal sign SQRT open parenthesis. Kasi yung ating equation may square root na. So, equal sign SQRT open parenthesis. So, it will take the square root of whatever is inside that parenthesis. Sobra ng t. Yan. So, ano yon? So, sabi natin doon, sa numerator ng square root, that's the sum of x minus x bar. So, select mo yan. Excuse me. That's the sum of x minus x bar divided by the number of measurements minus 1. So, kumbaga, that's 10 minus 1. So, wag mo na i-ano sa wag mo na i-asa sa Excel yon. Ikaw na mag-subtract. 10 minus 1 is 9. Type mo na lang 9. And then, press enter. You will end up with the same answer, di ba? Round off mo na lang siya using this portion here. So, yan. That's how you do this sa Excel. So, yan. So, yan yung mga shortcuts sa Excel. And gaya nga nasabi ko, important sa work kapag alam nyo na yung Excel nyo. Okay? So, bigyan ko lang kayo ng ng tingin sa aking Excel nung ako ay nagtithesis. Pakita ko sa inyo kung gaano kalala pag nagthesis kayo, no? Unless yung thesis nyo ay hindi siya experimental, no? Akin kasi experimental eh. So, papakita ko sa inyo kung gaano kalala ang Excel. Ang daming numbers na nakalagay. Excuse me. Ayan, madali pa lang, di ba? Ganyan pa lang. Pero pag pumunta kayo sa next worksheets, bulaga, ang daming number, di ba? Maski computer naglalag. Okay. So kailangan alam nyo na how to use the equations sa Excel, how to modify the graphs, no, how to insert error bars. By the way, yung error bars, ito yung measure ng standard deviation, no? So you have to include that sa graph nyo kapag kayo nagtithesis. Etong aking error bars dito, ano naman siya, pasok naman siya sa 5%. Kaya feeling nyo malaki, pero pasok yan sa 5%, no? Kaya okay lang yung error bar ko na yan. Okay? So, pero mas ideal pa rin kung maliit lang yung error bar, no? So, ganun. Sa absorption kinetics ko, this is the rate of absorption over time. Ganyan karaming data yung aking dinil. Meron pa dun sa kabila. And ito yung mga iba't ibang equations na ginamit ko. Okay. Bulaga, ang daming numbers. Ayan, dito kami gumagamit ng Pearson correlation coefficient. Don't worry, gagawin nyo rin to sa biostats, ha? So yan, again, error bars, itong error bars ko, pasok yan sa 5%, kaya okay lang dyan. Although, hindi ako satisfied, no? Kaya, yan. I'm feeling ko I need to expand this research pa. No? Marami pa akong pwede gawin dito. Pero at least it's good naman. It's good naman. Good. Pero we want the best, di ba? So yun. Okay lang yung error bars na yun kasi pasok sa 5%. And then lastly, I have my absorption isotherm. It tells us kung paano dumikit yung metal. It could be by chemical reaction or physical reactions. Okay? So yan, again, may error bars. May iba't ibang equations na ginamit. You can use the Pearson, the R squared, the slope equation. You can use the Excel to solve for the slope and the intercept. Okay? So ganun. Please maximize the use of your Excel. Basta alam nyo mag-Excel, dali na lang yung buhay. Also, additional lang uli, ito last na to. 'Di ba pag kayo gumagawa ng SPSS, ay gumagawa ng t-test ANOVA, you usually use SPSS kasi madali, no? Ako kasi baliktad, I find SPSS parang ang dami kasing options eh. I find it too technical. Ang daming ganap, no? So, you can actually use Excel to create the results, no, to recreate the results given by SPSS din. Pwede kang gumamit dito ng mga ANOVA, t-test, f-test, yung test for variance, no. Pwede mo gamitin yung Excel for that, no. So, alam ko may type ka lang dito, may in-enable akong option dito eh. Yung basta ginugol ko lang kung paano i-open yung option na yun. And then, I will just select certain data points. Then, pagka-press mo ng enter, lalabas itong result na yan. As in, lahat ng yan. Then, ikaw na bahala mag-interpret yan. Di ba? Kapag nag-i-interpret tayo ng hypothesis natin, if greater than 5%, then, ano na yan, insignificant. Kapag less than 5%, then, yan ay significant, 'di ba? May mga ganun. Minsan baliktad pa nga, 'di ba? So 'yan. So doon mo pwede makita yung ganyan. Okay, so again, you can use Excel, no, to solve for the t-test, the f-test, and the ANOVA. So you can explore that. Okay, so sa ngayon pa lang gusto ko explore nyo na kasi later on pag kayo nag-thesis, basta alam nyo gamitin yung Excel nyo, mas mapapadali buhay nyo dito. Okay. So imagine nyo, itong thesis data ko, ni-rush ko yan. 2 weeks lahat yan. 2 weeks lang kasi tinamad ako eh. Parang lumipas yung ilang buwan. Happy lang kami. As pagdating ng February, kailangan ko na-graduate. Ayan, ni-rush ko yan. Pero okay naman. Okay? Basta alam mo gumamit ng Excel, dali buhay mo. Okay? So that's all for today. I want you to answer the second part of the worksheet na lang. Okay? And I will give the answers by weekend. Bukas na pala weekend, no? Ang bilis, no? Tapos na agad February. So we are approaching the anniversary of the lockdown. No? So yan. Pakisagot na lang ito. And then I will upload the answer by weekends. Then yan, we're good to go. Next week will be the founding anniversary of FEU. So there will be set of activities, no? Please attend those activities, no, para ma-enjoy nyo naman yung tuition fee ninyo. Okay? So yan. Pero hopefully mag face-to-face classes na in the near future, no? Kapag lahat tayo vaccinated na. So yan, kasi pag face-to-face ganap sa FEU, nakita mo talaga yung banda in person, no? So last year, andun yung yung Ben and other people. Hindi ko nakilala yung iba. Pero yan, enjoy doon kapag anniversary. Kaya punta ka ng UST, may kapitbahay ka, no? Pagpaskuhan, so ganun. 2023 pa ba? Tagal. Hindi, kaya yan. Hindi natin sure, no? Pero hopefully yung LGU nyo may na, ha? Sana meron na silang vaccination program. Ako nag-sign up na ako sa Valenzuela eh. Kaya sana kayo rin. Okay? So yan. Sa Pasig, Valenzuela, Antipolo, no? QC, sana lahat meron ng vaccination programs. Okay? So by the way, kung sino man nasa Catanduanes sa inyo, mag-ingat sa inyo. Mag-ingat kayo kasi lumindol daw kaninang umaga according sa NDRRMC text, no? So please stay safe lang always. Okay? So that will be all for today. Let's have lunch. Late na rin naman. So thank you for attending this class. I will see you again next week. Bye-bye and ingat as always. A copy of the class recording will be uploaded on YouTube.